A battered chunk of bronze found on a sunken Roman ship should have been just another relic. Then, a forgotten museum drawer revealed a 2,000-year-old machine, its inner workings defying history. The moment felt impossible. Scientists thought they had cracked its secrets, a cosmic calculator for the sun, the moon, and eclipses. But a final unsolved cluster of gears forced them to look deeper. Their latest discovery confirmed the impossible. The device encoded planetary movements and hinted at knowledge the ancient world should not have possessed. The consequences go further. The last function they uncovered does not just challenge our timeline, it suggests someone wanted this knowledge buried. The question is not just how the Antikythera mechanism worked, it is why it vanished, and what else disappeared with it. Spring 1900. A battered sponge boat rides out a storm off the cliffs of Antikythera, a speck of rock between Crete and the Peloponnese. When the weather breaks, Captain Dimitrios Kontos sends his divers, men from Simi, used to risking everything in the deep, down to hunt for sponges. At 40 meters, Elias Stadiatis drops through a haze of blue and lands on a seabed littered with marble arms, broken faces, and twisted bronze. For a moment, he thinks he has found a graveyard. He surfaces in panic, raving about corpses. The crew laughs until more divers descend and come up clutching fragments of ancient statues, their hands shaking from cold and fear. Word reaches Athens. The Greek Navy dispatches the Mycale, and soon the world's first major underwater archaeological dig is underway. Divers in heavy canvas suits, tethered to the surface by air hoses, stagger across the wreck at depths up to 60 meters. The pressure is unforgiving. Some men collapse from decompression sickness. At least one never comes back up. The salvage continues anyway, driven by the promise of treasure and national pride. Over months, the team hauls up marble gods, bronze horses, glassware, and amphorae packed with the residue of vanished cargo. Among the debris, a lump of green-stained bronze, crusted with barnacles, is tossed into a crate. Just another artifact, no more remarkable than a broken helm. It travels to the National Archaeological Museum in Athens, where it sits, drying and quietly fracturing. In 1902, museum curator Valerios Stais examines the corroded mass and sees something no one expects: a tiny bronze gear, teeth still visible through the incrustation. He calls in colleagues. They chip away at the crust and find more gears, more fragments, all impossibly intricate. The artifact is cataloged, but no one can explain it. Some call it an astrolabe, others a clock. The truth is harder to face. Nothing like this should exist in the ancient world. The gear teeth are less than 2 millimeters apart. The mechanism's complexity defies every expectation of what Greeks or Romans could build. For decades, it remains a curiosity, an object pulled from the deep at the cost of blood and breath, waiting for someone to understand what it is and why it was lost. By the middle of the 20th century, the Antikythera mechanism was no longer just a curiosity. It was recognized as something far stranger, a device that should not exist, an impossible object, built with a precision no one thought possible for its time. The first real breakthrough came in 1958, when Derek J. de Sola Price, a physicist turned historian, traveled to Athens and examined the fragments up close. He saw not just gears, but a logic, a system. Price spent 2 decades piecing together its functions, using X-ray images, hand-drawn diagrams, and the emerging science of gear trains. In 1959, he published his first bold claim. This was an ancient Greek computer, a machine designed to predict the motions of the heavens. The front of the mechanism carried 2 main dials. One showed the path of the sun through the zodiac. The other tracked the days of a 365-day year. But the real magic was hidden inside. A network of at least 37 bronze gears, some with teeth spaced less than 2 millimeters apart, drove the entire system. Turning a single handle set the whole train in motion. The device could display the position of the sun and moon for any chosen date. It did not just show their place in the sky, it calculated the phase of the moon, using a miniature black and white sphere that rotated as the gears turned. This sphere was driven by a differential gear, a kind of mechanical computer that would not appear again in Europe for over 1,000 years. One of the most ingenious features sat buried in the heart of the mechanism, a pin and slot device that forced the moon's pointer to speed up and slow down, just as the real moon does in its irregular orbit. The Greeks called this the lunar anomaly. By building it into bronze, the mechanism captured a subtlety of celestial motion that even modern clocks ignore. On the back, 2 spiral dials held even more secrets. The upper spiral tracked the 19-year Metonic cycle, a period after which lunar phases realign with the calendar, essential for timing festivals and rituals. The lower spiral, the Saros dial, marked a repeating 223-month eclipse cycle, letting its user predict when and where eclipses would occur. A small subsidiary dial likely tracked the 4-year cycle of the Panhellenic Games, anchoring cosmic events to the rhythms of Greek public life. By the early 2000s, high-resolution X-ray tomography revealed the full depth of this engineering. Researchers mapped out the gear trains in detail. The work confirmed Price's vision. The mechanism could predict solar and lunar eclipses, track the sun and moon through the zodiac, and model the moon's shifting speed. But one cluster of gears, nestled in the upper back section, resisted every attempt at explanation. For all its astonishing capabilities, the device still held back its final secret, a function no one could yet decode. In 2021, a team led by Tony Freeth at University College London took another look at the Antikythera fragments. Armed with micro-CT scans and advanced 3-dimensional modeling, they set out to solve the puzzle that had defied generations. They focused on the orphaned cluster of gears on the upper back. Earlier researchers had mapped the sun, the moon, the cycles of eclipses, and the 4-year rhythm of the Greek games. But 5 mysterious pointers remained unexplained. Freeth's group began by tracing faint inscriptions, planet names, and orbital periods, etched on the battered bronze. Then they matched those traces to surviving gear stubs and tooth counts, searching for a pattern that fit both the physical evidence and ancient astronomical tables. What they found changed everything. The mechanism was not just a lunar solar computer, it was a planetarium in a box. Each pointer tracked one of the 5 planets visible to the naked eye: Mercury, Venus, Mars, Jupiter, and Saturn. But the real shock came in how those planets moved. The gears did not just turn smoothly, they looped backward, then forward, mimicking the strange retrograde motion that had baffled skywatchers for centuries. This effect, where a planet seems to halt, reverse course, then resume its path, was a signature of ancient epicyclic theory. To reproduce it in bronze required nested gears, pin and slot followers, and coaxial tubes, all squeezed into a space less than 2 centimeters thick. The University College London team's reconstruction showed that the Antikythera mechanism could model the apparent wandering of every major planet, not as random orbits, but as a precise dance governed by mathematical cycles. This was not a simple calendar or a teaching toy. It was a cosmic engine, encoding the machinery of the heavens with a sophistication no one expected from the ancient world. The boundaries of what Greek engineers could build and what they understood had just been redrawn. The Antikythera mechanism's reputation rests on numbers that defy belief. Inside a box barely bigger than a shoebox, ancient craftsmen packed at least 37 interlocking bronze gears, Some of these gears have teeth spaced less than 1.5 millimeters apart, so fine you could fit 10 across a thumbnail. The calendar ring, a thin bronze band now broken and corroded, once held 354 or 355 tiny holes, each marking a day in a lunar year. Modern analysis shows those holes were punched with an average radial error of 0.028 millimeters, less than the thickness of a human hair. The precision goes further. Each gear had to mesh perfectly with its neighbors, or the entire train would jam. The mechanism's coaxial tubes, nested bronze cylinders that carried pointers for the sun, moon, and planets, had to align within 1/10 of a millimeter along their length. Every misstep in cutting, every slip in filing, would ripple through the system, throwing off the cycles it was built to predict. Reconstructing this device today, even with digital calipers and CAD models, pushes engineers to their limits. But the original makers worked with hand tools, files, bow drills, and simple lathes. There are no surviving blueprints, no half-finished prototypes scattered in a workshop. The device appears fully formed, as if it sprang from the hands of artisans whose names are lost. This isn't just a matter of technical skill. The tolerances required for the Antikythera mechanism are so tight that even a seasoned modern machinist would need patience and luck to match them. To cut a gear with 127 teeth, each one identical, using only a scribed circle and a steady hand, borders on the impossible. Yet the evidence is there, etched into corroded bronze. Someone somewhere achieved it. The question isn't just how the mechanism worked, but whether it could have worked at all. The numbers suggest a level of precision that should have been out of reach, and yet the machine exists. That contradiction lies at the heart of its mystery. Greek letters, barely a millimeter high, crawl across every surviving surface of the Antikythera mechanism. These are not decorative flourishes or simple labels. The text, over 2,000 characters in total, reads like a technical manual, squeezed onto bronze plates and dial rims. Modern imaging, from micro-CT scans to polynomial texture mapping, has revealed instructions for setting dials, calibrating cycles, and interpreting the device's many outputs. The writing explains how to align the calendar, how to read the eclipse spirals, and what to expect from the moving pointers. Yet even as the text guides, it also puzzles. One section tied to the Saros dial on the back catalogs eclipses not just by date or type, but by color. Some eclipses are marked black, others red, a few fiery. The meaning is not obvious. Ancient astronomers had no theory for why a lunar eclipse might turn blood red one year and vanish in darkness the next. Was this a record of atmospheric dust, a coded warning, or a relic of older Babylonian omen traditions where the color of the moon could signal disaster or peace? The color adjectives stand out because they are systematic, grouped by cycles, not by single events. Epigraphers working with the Antikythera Mechanism Research Project have debated whether these color codes reflect real observations or predictive categories assigned by rule. Some argue they are empirical, tied to eclipses witnessed under strange skies. Others see them as algorithmic, a way to compress centuries of skywatching into a few words. Corrosion has erased much of the inscriptional detail. In places, the text fades into the bronze, as if lost to time, or as some have speculated, deliberately worn away. The ambiguity lingers. Are these gaps the work of the sea, or of someone who wanted the machine's knowledge to remain incomplete? What survives is enough to show intent, a manual for users who were expected to understand not just when the sky would darken, but what kind of darkness to expect. No craftsman's name appears anywhere on the Antikythera fragments. No workshop stamp, no dedicatory plaque, no proud signature scratched into bronze. The device's instructions are written in precise, technical Greek, a language suited to mathematicians and astronomers, but the words themselves refuse to name a maker. The device remains anonymous. In an age when engineers carved their names into aqueducts and artists signed statues, proud attributions were common. Scholars have searched for clues in the style of the lettering, the calendar terms, and the mathematical vocabulary. Each detail points to the Eastern Aegean, to the world of Rhodes, where philosophy, astronomy, and navigation flourished in the last century before Rome's rise. Ancient sources describe orreries, mechanical models of the heavens, built by Posidonius, Rhodes' most famous philosopher. Cicero wrote of a device on Rhodes that mimicked the motions of the planets with gears, much like the Antikythera mechanism. But the connection is circumstantial. No inscription ties this machine to Posidonius or his school. The craftsmanship suggests a tradition of astronomical instrument making, not a solitary genius. Yet the silence is striking. The mechanism's precision, gear teeth spaced within a hair's width, cycles encoded in bronze, demands a master's hand, but history has erased the face behind the work. The loss is not just technical, it is personal. A tradition capable of such a device left behind only a mute, shattered legacy, its creators' names washed away by time and the sea. The Antikythera ship's manifest reads like a catalog of Greek splendor. Dozens of marble statues, bronze figures, luxury vessels, and amphora packed for a westward journey. Archaeologists date the wreck to around 70 to 60 BCE using coins and ceramics scattered across the seafloor. The destination was almost certainly Italy, the heart of a Roman world hungry for Greek art and prestige. Amid the cargo, the mechanism stands out. It is not a statue, not a votive, not a trophy. Its bronze weight is trivial next to the hulking figures of heroes and gods. It offers nothing for the banquet table, nothing for a temple. No records explain why a device, built for calculation and prediction, something only a handful of scholars could read, was packed alongside objects meant for display. The mechanism's presence in this shipment does not fit the logic of loot or tribute. It is a singular scientific tool, out of place in a cargo hold designed for public spectacle and private wealth. Some historians see a pattern, Greek knowledge boxed up and sent west, not for celebration, but for removal. The ship's sinking sealed its fate. The machine never reached Rome. Its silence is the only clue that something more than art was being spirited away. Roman writers filled libraries with treatises on architecture, engineering, and natural wonders. They cataloged sundials, water clocks, even mechanical toys. Yet not a single surviving Roman text describes a device like the Antikythera mechanism. Cicero marveled at a celestial sphere owned by Posidonius, a machine that mimicked the heavens, but he left out any mention of gears, dials, or the secrets of its workings. Vitruvius, in his exhaustive survey of machines, described water clocks and armillary spheres, but offered no instructions for building a compact, gear-driven computer. Pliny the Elder, who wrote about everything from earthquakes to automata, remained silent on the subject. This absence is not just a quirk of lost manuscripts. Rome absorbed Greek knowledge, imported Greek experts, and displayed Greek wonders in public spaces. But when it came to the tools that predicted the sky, when, where, and how the heavens would shift, Roman literature falls silent. Eclipses and planetary alignments were matters of state, their interpretation reserved for priests and augurs. Divination was regulated by law. A machine that could predict such events with gears and numbers risked stripping power from those who claimed to read the will of the gods. The Antikythera mechanism vanished into this silence. No Roman manual, no imperial inventory, no public display. If such devices reached Rome, they disappeared into private collections, their knowledge sealed away. The record is empty where it should be loudest. That emptiness is not an accident. It is the shadow of a world where knowledge could be owned, hidden, or quietly erased. What disturbs scientists now is not just lost knowledge, it is the proof that advanced ideas can vanish, leaving no trace for centuries. As ancient secrets resurface through technology, we face a stark reality. History's greatest breakthroughs are not always remembered. They are rediscovered. In an era of fragile data and shifting priorities, the true lesson is simple. Civilization's memory is thinner than we think. What else are we forgetting? Let me know your thoughts below.